All right. So what do we have for today? We have metals, right? Metals, right? When we talk about metals, obviously, what are metals? Generally, we were able to understand that elements in group 1, group 2, and group 3, some in group 4, and some at the very bottom in group 5 are basically metals, right? And transition metals. Transition elements are mostly metals. All right. Generally, if you would want to look at the periodic table, you would want to look at the metals. That is where you're going to find them, most of them. And then we know left side of the periodic table are generally metals, right? And it is the left side in which the metallic property actually increases. All right. Then important point that we have to understand here is the property of metal and their structure and their structure. Properties of metals related to their structure. Basically, this is what is this going to have? This is we are going to be talking about their bonding, the arrangement. Generally, when we discuss the properties of metal, we say that the properties of metal are generally due to their arrangement, due to their bonding, due to their structure. All right. So the things that we have to consider in this is going to be the bonding in metals. All right. Arrangement of particles, arrangement of atoms. All right.
Yes.
The properties, generally, when we talk about them, the properties of metal that we come across are due to these two important factors: bonding and their arrangement, the structure. All right. So what is that? When you talk about it, we say that in metals there is metallic bonding, right? What was metallic bonding? Metallic bonding was attractive forces between the positively charged atom and the sea of electron, the mobile sea of electron. All right, mobile sea of electron. This is what caused the metallic bonding. And due to strong metallic bonding, due to strong metallic bonding, due to strong metallic bonding, metals have number one, high density. All right, high melting and boiling points. All right, do you understand? The particles are being held together very closely by the sea of electrons. If you look at a metallic structure, this is how it is going to look like, right? And they are held by electrons together, mobile sea of electrons. And this mobile sea of electron, if any of this particle or any of this atom would wants to move out, this is, let's say we have found a piece of sodium. This is what the bonding and the atomic structure generally looks like. All right. The ions, they have lost their electrons. Let's say this is sodium, so each atom has lost an electron, and those electrons have formed a sea of electron moving around, and they do not allow any of the particles to move out. They strongly keep those positively charged ions together, holding them in their position. You can take this as if that if you make a jelly and you spread marbles in it. You take a jelly in a or you take a liquid glue in a tray, and then you sprinkle marbles over it, so the round balls, the glass balls, marbles, and you sprinkle them all around. You see that they get stuck in it, they get fixed in it, they're not able to move around. You can think of the jelly or the glue as you can think of the jelly and the glue as the sea of electrons, which is not allowing any of the marbles to move around or even to come out. Do you understand this point now?
Yes.
So this is how it is. So this metallic bonding, you have to think of metallic bonding as what? As as a tray of glue and some marble balls spread over it. All right. This is how metallic bonding is. Okay. So this is what cause. This
Yeah.
is what gives this is what gives them an ability to conduct electricity as well. Right. We'll write that point as well. So the second point that we have to keep in mind is that in a pure metal, a pure metal is going to have what? Metallic bonding. So in a pure metal, atoms are packed tightly, packed tightly, or arranged in a regular tightly clo- clo- uh, closely packed manner. Tightly packed tightly. Remember, this is the characteristics of solid that we have already studied. In solids, the particles used to be tightly packed together. Remember, in liquid they were loosely packed, and in gases they were widely spread. This is the arrangement that you have to keep in mind. All right.
Yes.
So they are. Yes. Any questions?
No questions.
In regular arrangement, in layers, as we have already drawn in layers like this. So there is a layer of positively charged ions, and in between there is a sea of electron. This is generally what is proposed. So that is why they become so once the force is applied, what happens? They slide over. The layers slide over each other. So if a force is applied, if somebody is going to hammer this, what is going to take place? This is what it is going to become. the electrons. So this is how they change the shape. Do you understand? They slide over each other. All right. So this arrangement, the metallic bonding, and in the layers and the tightly packed arrangement, and the sea of electrons, especially the sea of electrons, especially. This is due to what? Due to two reasons. Number one, arrangement in layers, and number two, sea of mobile electrons. They slide over each other. This gives them a property of what? Being soft. Some metals are soft. Ductile. Ductile. What is ductile? They can be drawn into fine wires. Ductile means they can be made into wires. Made into wires. All right. This makes them soft, ductile. And number three, malleable. Malleable means what? They can be beaten into sheets. They can be beaten, hammered into different shapes. This malleable means hammered into different shapes or sheets. Do you understand this point, everyone? Any queries up till now?
No.
No, sir.
All right. Soft, ductile, and malleable. This is what makes the metal, this arrangement. All right. And the third property, so we are going to write what we are getting out of them. We're going to write what we are getting out of each of these. Even though I'm able to write them, this is what becomes because of this arrangement. Ductile, soft, ductile, and malleable. Due to their to the very strong metallic bonding, they have high densities because they are closely packed together, and they have high melting and boiling points, because in melting and boiling you need to overcome that force that is keeping the atoms together, right? So if you break the metallic bonding, you need a lot of if you want to break metallic bonding, you need a lot of energy. You understand? Similarly, one is the third aspect that is there is the sea of mobile electrons make sea of mobile electrons make metals good conductors of electricity. Make good conductors of electricity and thermal energy, heat, and good conductors of heat, right? So if you're going to heat them from one end, we know, we have already studied that in metallic bonding, that the positively charged atoms, they do not move. It is only the electrons that are mobile, right? They are fixed, they cannot move. It is only the electrons that are mobile. They can move around, they can go here and there, they can go anywhere they want, right? They're like flowing around. So when you give them the heat, these electrons, they gain energy, and they pass this energy in kinetic form, right? In kinetic form to the other electrons that are there, and eventually this energy spreads out in all of, if you start heating the metal from here, this energy will spread out all to the end. Why? Because if a metal rod is heated at one end, all right, the electrons on that end gain kinetic energy. They gain kinetic energy, Ke. They gain kinetic energy and pass them on to the others, spreading it out eventually. Even, or you can say eventually spreading it out. Really spreading it to the other end. You understand this point?
Yes.
The particles over here, they are going to gain kinetic energy, the electrons, and they're going to move around very fast. This fast movement, kinetic energy, is going to be passed on and on and on, and ultimately this heat energy is going to be transferred. Is this clear? Right?
Yes, sir. Yes.
We know the most metallic compounds that we have are in the group 1. Remember, I told you that group 1 is the most metallic, the most metallic elements that exist in this world are in group 1 are the group 1 elements, and the one which is at the most bottom of the group 1 is the most metallic. He's like a prophet of metals, right?
Yes.
So we know that pure metals generally are what? The most pure metals that we have are generally soft, all right, and they're reactive. The most pure metals. So we have understood few things. What is that? That we have been able, we up till now we have been able to explain few things. What is that? We have been able to explain why metals why metals have such properties. Why metals have why metals are, number one, uh, high. Why do they have high density, right? Why do they have high melting points and boiling points, right? We know why they are good conductors of heat and electricity, right? With the bonding and with why are they ductile, soft, and malleable? We have been able to explain all of this up till now, right? Now you should be able to explain why do they have high density, because of the metallic bonding, a strong metallic bonding, because they are held very tightly close to each other because of the CF electron. Why do they have high melting boiling points? Because they have a very strong metallic bonding. The CF electron does not allows the particles to move from the positively charged atoms to move from their place. Why are they good conductors of electricity? Because they have a sea of mobile electrons. Those mobile electrons are moving around. If they gain energy, they quickly move from one end to another. That is how they can conduct electricity very quickly. Why are they ductile and malleable? Because they are arranged in layers, and between each layer there is a sea of electrons. So when they are pressed or pressurized or hammered, they can easily be stretched out. Those layers, they slide over each other and they can form good wires. They can form good sheets because they can be hammered into different shapes. You understand all of this? But there's something, some now these pure metals are very good to know their properties of. It's good to know their properties, but the thing is that there are few shortcomings that we face. Pure metals, they have few issues. There are few issues. They are soft. They are soft. This soft does not mean that they are soft. You can easily squish them or something like that. It's not like that. It's not that you can just press them and they are going to bend into different shapes. No, they are soft for the daily, for our daily use, for our industrial use. The reason we need metals for, they are soft for that. All right. So they are soft. Secondly, they are corrosive, very reactive. They are very reactive, right? They corrode, very reactive. So they react with air and water. Remember, they react with air and water. So they corrode. So they corrode. All right. Or they have low resistance to corrosion. They cannot last long because they are very reactive. They are going to form oxides, and those oxides are not pure, and they are going to become weaker and weaker, and they are going to lose their structure. Is this understood? Is this clear?
Yes,
Sir,
sir.
can you explain again?
Yeah, we are saying that we know all of these good properties of metals. We have already understood now, right? But we say that pure metals have these all of these properties are of pure metals, right? The pure metals, they are soft. The two problems that we face when we want to use those metals in our daily life and in the industrial uses, their application becomes difficult. It is difficult to use them in our daily life, those pure metals. Why? First of all, they are very reactive. They react with air and water. Once they are going to react with air and water, they will corrode, they will get rusted, right? Like iron
Yes.
is rusted when it is exposed to air and the moisture in the air and its moisture and the water, or damp places. You understand this point? So
Yes, sir.
so that is why those pure metals, we do not really use metals in their very pure form in industry or our daily use. All right, that is why the two reasons: they are soft, they cannot withstand large pressures, they cannot withstand high forces. All right. Secondly, they are very reactive, they corrode, they get destroyed. You're going to put a pure iron grill, and after a few years, it's going to be gone. Why? Because it will be rusted, and then it will break off and corrode. You understand? They wear out very easily. They wear out. So that is why we do not use them. That is why we mix them with other substances. That is why we make alloys from metals. All right. We make alloys for metals for our industrial use. Do you understand this point? The alloys.
Yes.
Yes.
All right. And then this brings us to another concept of on the same topic, the alloys. Alloys. All right. I think before we directly go into alloys, it's okay. We can discuss alloys, then we can discuss the the two different the difference between the metals and the non-metals, and they just summarize that for you, inshallah. All right. So alloys. When we talk about alloys, what are alloys? An alloy is a mixture. Mixture. Okay, keep in mind it's a mixture. It's not something that is chemically bonded. It is a mixture of a metal with one or a few other elements. Those elements could be metals and non-metals. All right, they can be metals. Those elements can be metals, or they can be non-metals as well. All right. All right. So some example can be, this is very important. Bronze, that is something very common that we use. Bronze is an alloy of copper and tin, right? Similarly, we have brass. Brass, very commonly used. You use a lot of uh, uh, handles, knobs, brass. Brass is an alloy of copper and zinc. Zinc. Stainless steel stainless steel is an alloy of, it's an alloy of iron, chromium, and nickel and carbon, right? So stainless steel that we have, the jewelry that we use of stainless steel, other utensils that we use, is made up of basically iron, chromium, nickel, and carbon atoms mixed together. You have to keep that in mind. So what is going on? They are basically, let's say this is copper atoms and this is zinc atoms. So copper and zinc is going to be melted. It's going to be melted and then it's going to be poured in a same in a same mold or whatever it is, so that it can be shaped into a certain, or it could be create a bar could be created, or whatever needs to be made. So this is how they are arranged generally. So when they mix together, this is how they get arranged. So we have copper atoms and a zinc atom, and a copper atom and a zinc atom. All right, or let's not, we have a copper atom, we have a zinc atom. A copper is zinc, a copper is zinc, a copper or zinc and a copper. This is how they are arranged. So this is, if you're going to find something like that, the physical appearance is going to be a bit different from zinc, a bit different from copper. It's a mixture, you see. It's not, they're not chemically combined together. This is what you have to keep in mind. Alloys are not alloys are not formed out of bonding. The atoms of copper and zinc are not bonded together. You have to keep in mind, not bonded. All right, because we know metallic bonding only takes place within one element, right? Metallic bonding can only take place within one element. Only all the copper atoms can be bonded metallically. All right, all the zinc atoms can be bonded metallically, but copper and zinc, those two different elements can, even though they are metals, they cannot bond together with metallic bonding. Do you understand this point?
Yes.
All right, so copper and zinc, this is how they are going to look like. All of them, brass and the bronze, this is how they are mixed together. You have to keep that in mind. They're not bonded, but a mixture. Mixture, okay, mixture of atoms. It's a mixture of two elements. This is how they are made. All right. So obviously, we have already discussed why do we prefer alloys over metals. Why? Now we'll talk about that. Why alloys? Why alloys are better than? Why are alloys better than metals in our daily industrial use? Right? Number one, metals can be made harder and stronger. Remember we said they were soft, right? So if you look at brass is stronger than copper or zinc. All right. So when they are mixed together, they become stronger. You understand? Brass is an alloy of copper and zinc. So copper individually and zinc individually, they were not very strong. They are made strong when they're mixed together. They become stronger. All right. And why does this takes place? This takes place. This is due to this phenomena. This is due to the difference. This is due to the difference in size of copper and zinc. All right. So what we were able to see in our previous sessions, we were when we were discussing metals, we were able to see that the metals, they were of same, the all atoms were of same shape, all of same size and shape. So they used to slide over each other. They could easily slide over each other, right? But now when once we have a difference in shape, all right, when we have a difference in shape, it becomes difficult for atoms to slide over each other. Do you understand this point?
Yes.
It becomes different for them to slide over each other. Now they cannot slide over each other. It becomes difficult for this for the difference in the size. This makes them, they lose